With the Indian solar market plowing ahead towards its 100 gigawatt target, quality concerns have been raised against the backdrop of an extremely price-competitive market. In a bid to avoid mass failure of solar plants a few years down the road, the National Solar Energy Federation of India has joined forces with India's Bureau of Standards to set new rules for market access in India. Final implementation is yet to come, but the outlook gives good reason to focus once more on the quality debate. It is therefore that we are happy to welcome once again representatives from right across the PV industry to our Quality Roundtable event held at New Delhi's Renewable Energy India Expo.
Now, just to lead into this discussion, I wanted to present just something very quickly from PI Berlin, and a number of other partners did some analysis of projects out in the field in India. They were essentially looking for projects that were underperforming. They used Discom data. They found 50 or so projects. They also wanted projects that had 12 months of continuous data, so that narrowed the field down even further. They found 20 projects in the end, 15 here in Delhi, so very relevant to the conditions that we experience in this part of the country. But then when it came to what was really impacting the power output most, I think this is a really stark takeaway. PID, performance induced degradation, really huge impact in terms of the power output of these arrays that were underperforming here in India. And it's also worth noting that these are arrays that were under 4 years old.
Potential induced degradation describes leakage currents or unwanted electron movements to the module's glass cover or frame. The effect causes, among other things, anti-passivation and an increase of the surface recombination loss rate. Other effects can be neutralization of the doping of the silicon. Each of these effects cause the module to lose power, with some of the effects being irreversible. Because PID is caused by electronic potential between the cell and the ground, the degradation is accelerated by higher system voltages, as they found in large ground mount arrays with 1500 volt systems, for example. But other factors also play a role.
This is much connected with the humidity aspects. So, humidity are very high temperatures. In Gujarat and Rajasthan, you may see very high temperatures. In Chennai or on the downside, when you see West Bengal, there will not be humidity aspect. So somewhere or the other, when there is a mix of these conditions, this is what relating to the PID. Now, coming on to how to arrest it, the only way is the lamination process. If you have the best lamination process at the manufacturing level, it is guaranteed that you can avoid this PID. How you can do it? This is keeping the proper creepage and clearance distances in the module. If the cells are kept away from the frames or the bus bars or the strings or the ribbons, whatever you call it, the conductive path, if you can isolate to the extent from the frame, you can avoid this.
But as George Touloupas of CEA explains, module manufacturers are constantly testing internally for PID susceptibility of their modules. He also explains that it is really important to subject each product and not just manufacturers to continuous third-party scrutiny. He observed fluctuating performance of the same product as the bill of material changes over time.
If the cell stack changes, because the cell is very important, if there is a process change because it has a downside on the efficiency of the cell, the protection layer, or if the EVA, the encapsulants properties change, the volume resistivity goes down for some reason. Yeah, lots of things can go wrong. These two are the main drivers, and the lamination is not done properly, you can have disaster.
This brought the discussion around standards back on stage, but not everybody was convinced that standards alone would help the situation.
Any standard that you come up with, that's going to be a design certification standard. Okay, so you can certify a module design, but when you're actually getting cells and modules, who is looking at those cells, right? If those are, you need to have some continuous testing of cells and modules to ensure that the newer batches of the same design are also equally PID resistant.
Industry representatives have yet to be convinced that a bespoke Indian testing regime is a good idea. The concern is that most of the modules are already checked by globally well-renowned labs where they're produced, so why would somebody do the same job again in India? Additionally, double testing protocols are likely to come with a price penalty, which could slow down PV deployment. Moving the debate further, Quality Roundtable initiative partner DuPont shared results of having audited more than 2 gigawatts of installed PV capacity. Some of these installations had been in the field for considerable time, showing signs of poor quality encapsulants. Backsheet cracking, yellowing and delamination and other failures can be observed after just a few years in the field.
We do feel that as a developer investors, you really need to pay attention to bill of material, especially the backsheet, because all the backsheet looks pretty same. So you have to specify material in your standard. Okay, standard is critical for this industry. Without standard, without bill of material, there are high risk of failure of your module in the field, especially when you put into harsh climates like in India. Okay, will accelerate this kind of failure.
But even with a clean bill of materials, shipping and installation still have to go smoothly, or else catastrophic damages might entail. A quick discussion around the latest events of the rooftop fires on Walmart's roofs have demonstrated this importance. The supermarket chain filed a lawsuit against Tesla after a series of fires were caused by the PV arrays. According to the complaint, the fires have been caused by poor handling of connectors, which led to arc faults.
We are used to say the devil is in the detail. So it means here in the detail of the product itself, but also in the details of the correct planning, installation of the products.
The devil is in the detail indeed, but as the PV industry matures, the quality narrative is getting stronger, and some culprits of the past have been identified and eliminated. While there's work left to do, things are moving in the right direction.